Hi scientists, in today's video we're looking at why are units important. So our learning intention for today is to explain the importance of SI units. So firstly we need to describe what they are, we're going to identify some common SI units used, and then we're going to perform some unit conversions so we can express answers in SI units. So firstly, let's have a look at this tweet. What clothing would you wear based on this tweet? So it's 38 degrees today. Pause and have a think. All right, let's come back together. If you had said that you'd wear a t-shirt and shorts, well, maybe you'd be regretting that decision because 38 degrees Fahrenheit, which is an imperial system unit used in America, is actually only 3.333 degrees Celsius, which is a metric system unit used in Australia. So that's really cold. So the units when we express measurements are actually really important. And it can make it really difficult for scientists to communicate towards each other if they're using different units. So the SI unit is an international system of measurements that is used universally in technical and scientific research. So this avoids confusion of someone going, oh, 38 degrees, that doesn't seem that cold or that doesn't seem that hot, because everyone understands which units we're using. So for example, the SI unit for length is the meter. The SI unit for mass is the kilogram, and the SI unit for time is the second. And you'll notice that we've been talking about speed in meters per second. And the reason why is because those are the two SI units. And it just makes it really easy for the entire world to understand measurements if they're using one system. And it actually caught up scientists in 1999. They was working across America and the United Kingdom, and unfortunately, two different scientists were using two different types of units, and because of that miscommunication, it actually crashed and cost a lot of money. So it's important to use the right units. It's also important for trying to relate things to each other. So if you've got these three cars, car A, car B, and car C, it's very difficult to actually determine which one's going fastest because one's going 60 kilometers per hour, one's going 6 meters per second, another one's going 100 centimeters per minute. So by looking at it at face value, it's kind of difficult to figure out which one's going the fastest. So let's come back to this once we know how to convert these into the same unit, and let's do the SI unit of meters per second. So how can we do that? Let's have a look. All right, so we've got some units here. We have kilometers per hour, so 10 kilometers per hour, and we want to get that into meters per second. So the first thing that's the easiest is to take one of these sides of the units and convert it into either meters or seconds. I always start with the length measurement. So let's have a look at this, getting it into meters. First thing we need to think of, well, we know we've got 10 kilometers. How many meters is there in just 1 kilometer? And there's 1,000 meters per kilometer. So we've actually got 10 times 1,000 meters because every kilometer there's 1,000 meters. So now we know it's actually going 10,000 meters every hour. So the next step is to figure out, well, if it's going 10,000 meters every hour, what's it doing every second? So we need to get this into seconds. So we then think, okay, the same as before, we figured out there's 1,000 meters in 1 kilometer. How many seconds are there in 1 hour? So you could do this either in one step or two steps. Let's show the two steps first. So we know that there is 60 minutes to every hour. So we go 1 hour times 60 tells us the number of minutes. Then we know that there are 60 seconds in every minute. So 60 minutes times 60 tells us that there's 3,600 seconds in 1 hour. So if we put that together now, we know that this car, for example, that was going 10 kilometers per hour is actually doing 10,000 meters for every 3,600 seconds. These two things are the exact same. But you don't often see something expressed to 3,600 seconds. That's quite complicated. So we can simplify this to figure out, well, how many meters is it just doing in 1 second instead of 3,600? So if you put 10,000 divided by 3,600 in your calculator, you'll get 2.8 meters per second. So there we go. We start by getting this one into meters and then figuring out, well, it does that many meters every 3,600 seconds, and then we simplify. But let's go the other way now. So now we want to get meters per second into kilometers per hour. you're going to do a similar thing. You're going to put this into kilometers first and then figure out, okay, if it's doing that many kilometers every second, you times that to figure out how many it does in an hour. So let's start or break this down. If this is 5 meters, how do you express 5 meters as in kilometers? What is 5 meters in kilometers? So we know that there's 1,000 meters to every kilometer. So 5 divided by 1,000 is 0.005 kilometers. So these two things right now are equivalent. 5 meters and 0.005 kilometers are the exact same thing. So we know the car's going 0.005 kilometers every second. But now we want to know, well, how many kilometers is it doing in an hour? So we need to figure out how many seconds is there in an hour. And we do the exact same process as before. We know there's 60 minutes in an hour and there's 60 seconds every minute. So now we know that it's doing 0.05 kilometers every second. But we want to know how many kilometers it's doing in an hour. So we times it by 3,600. Because that will now tell us that it's doing 18 kilometers per hour. So these two things here are the exact same, but just different units. So if I said a car's going 5 meters per second, or if I said it's going 18 kilometers per hour, it has the same speed, but I'm just showing two different units. Now, you might be thinking, Miss, I've heard of a more easier way to do this. And there is another way. If you want to get meters per second to kilometers per hour, you can times it by 3.6. Or if you want to get kilometers per hour into meters per second, you can divide by 3.6. And that's okay if you understand that. But by actually breaking down the steps and doing it this way would mean that if they gave it to you in centimeters per hour or miles per hour, you won't get caught up on just memorizing if you times or divide. So I suggest breaking it down. So have a go at trying to convert the following speeds into meters per second and then the following speeds into kilometers per hour. So pause the video, have a go, write all the working out, and then come back to revisit the answers. All right, and hopefully you got those answers, and if you have any trouble with those, then see your teacher. So today we looked at what the SI units are and why they're important, and we looked at converting. So if we revisit this question right at the beginning, we now could convert these so that they're in the same SI unit, and we'd figure out that car A is in fact going the fastest. So we've met the following intentions. We know that the SI units are a standard system or internationally recognized system of units so that it's easier to communicate worldwide. We know that the SI units for different measurements like mass is the kilogram, length is the meter, and time is the second. And we're able to perform some conversions by breaking it down into how many meters were in a kilometer or how many seconds were in an hour. So well done, guys. Thank you.